Hello, this is Brian Killow from the CFmask Systems Engineering Office. I'd like to share with you a new data cube demonstration that we recently completed showing water detection from space. As we all know, water is one of the world's most valuable resources. Everything from water supply to quality to the risk of droughts and flooding can all be studied from space. You can see an example of this on the right with water stress by country. In many regions of the globe, it's a critical issue. The CFmask Data Cube gives us a unique way to look at time series data specifically targeted to water. The demo that I'm going to show you today is over Kenya in the Lake Baringo National Park. This national park's in central Kenya, as you can see on the Google map on the left, and a Google image of the lake is shown on the right. What we did to prepare for this analysis was gather data from Landsat 7 from January 2005 to April 2016. This is about 11 years of data. The background was 169 original scenes, which was 202 gigabytes of data. We pulled the pixels out of those scenes and put them into a 1 degree by 1 degree data cube stack, and then we store that in annual chunks. So you end up with 1 degree by 1 degree with annual tiles to reach a total of 11 plus years. The total number of pixels in the entire stack is about 2.3 billion, and with a 5:1 compression we could take the original scenes at over 200 gigabytes down to 37 gigabytes in the final data volume. We used a very simple Linux computer for the analysis, 3.5 gigahertz, 65 gigabyte of RAM. Not very expensive if one were to buy that. We then modified the Australian water detection algorithm, which has a very high accuracy of 97% for detecting water. And we were able to run annual analyses, which took 1 or 2 minutes apiece, and about 30 minutes for the full time series. And I'll show you these results. Here's what the Australian WOFS algorithm looked like. This algorithm is called Water Observation from Space, WOFS. And the example you see here is a river network of the Coopers Creek in Queensland. It's really an interesting plot because it shows the ability to see flood extent, which would be very difficult to pick up with static maps at any point in time. This allows you to look at a very dense time series and to assess areas that are prone to flooding. We implemented this 23-step algorithm and applied it to the new version 2 data cube. Here's an example that you see on the right, the time series animation. You will see drought conditions in the early years, and as the animation gets to 2011 and 12, you'll see the size of the lake growing considerably. So in the later years, 2013 and 14, the lake was quite large due to extensive flooding. In the early years, there was a good bit of drought. This is a picture you see here on the left of Lake Baringo in Kenya. And I'll explain the details of this result in a moment. Let's look at some of the pieces of this annual analysis. In 2006, what you see on the left, this was a period of extreme droughts. They had lots of impact on pastures and farming, and you can also see the minor Landsat banding, which are these streaks that occur across the analysis, and that's just because of a lack of data. With the Landsat 7 bands, missing data would mean when it tries to count the availability of water, it would miss out on some of those, and that's why you see the bands. In the central plot, 2013, they experienced severe floods. There was a report in Google of a displaced 600 families that were swept, livestock was swept away near Lake Baringo in 2013. And the interesting plot on the right in 2016, since it was only a 4-month period, those 4 months, January through April, are the dry season. And what you notice is little water was detected outside the lake boundary. So since it wasn't a very rainy period, you don't see a lot of water extent beyond the normal lake boundaries. Another interesting thing we found was when we compared the WOFS algorithm to something called CFmask, which is the USGS Land Cloud Quality Mask. This quality mask has the ability to detect water, but in some cases it misses the detection of water because it's only using limited information. The WOFS algorithm uses many of the Landsat bands in a multi-step algorithm, and what we found is we were able to detect Lake Solai just south, and you can see it at the very bottom of the image. The WOFS algorithm was able to detect the lake, but CFmask did not. And finally, this is the results of the 11-year analysis. What you see on the left in the results is any time that water is present 1 to 5% counted through the entire time series. That shows up in red. And as you approach blue, blue would indicate that water was there frequently or permanently. What this does is give you an idea of where the flood extent would occur around a lake like Lake Baringo. And as you see in the east and the south, it had 5 to 20 to 50% flood-prone regions, and there were also some more particular areas where you would see the red, which are very low amounts of flooding, but still the potential exists. In the bottom right, I picked out the very small sublake below Lake Baringo just to give you an idea of the depth of detail in this analysis. This 30-meter Landsat resolution would give you an incredible amount of information that might be far better than MODIS class data at 250 meters.